All right, hello everybody. Today we're going to be writing recursive methods. Okay, now hopefully you've already gone through the first part of this lesson and done the homework. We're really focused on just how recursive methods work. Okay, tracing through them, seeing how the recursive calls happen. Okay, today what we're going to get into is actually writing our own simple recursive methods. So first off, let's talk about why use recursion. Okay, and actually we're going to start off with why you shouldn't use recursion. Okay, first off, you never actually have to use it. Okay, any problem that can be solved recursively can also be solved iteratively, in other words, through loops. Recursion is really just a bunch of looping. Okay, when you're repeating the method, you're just repeating commands. So technically anything you can do with recursion, you can also do just with loops. Okay, also a big reason not to use it is recursion uses a lot of memory. In most cases, it is less efficient than the iterative solution. Let's take a look at a quick example of why that's true. So I've got two different methods, sumNums and sumNums, okay, which are basically going to sum the first n integers together. Okay, so you'll pass an int into each of them. The first one has a iterative solution, just a solution with a loop. Okay, for that, what's going to happen is we're going to have a sum equals 0. We're going to loop from n down to 0, counting down each time, and we're just going to add that I to sum and return sum. Okay, pretty straightforward, something we've been doing for months. Okay, very efficient solution. Okay, the alternative recursive solution isn't too bad to write here. Okay, first off, I have my base case. If n is just 1, I know the sum is just 1. So return 1. And then if it's not 1, we have the iterative case where what we're going to do is return n plus the method call sumNums of n minus 1. In other words, take the n and then add to it what we get from calling that method on 1 less. And that's going to repeatedly add that 1 less to it until I finally get to my base case and return the 1. Okay, so two pretty simple solutions. They both take about the same number of lines of code to write. They're both going to run pretty quickly. As far as memory goes, the first solution is going to be a lot better than the second solution. Okay, first solution, really all I'm doing is keeping track of 3 variables, an n, sum, and I. Okay, and those variables are just going to keep getting updated by Java each time that the I increases. Whereas in my recursive solution, each time I make another call to sumNums, I get another method frame added to my stack with its own set of variables, okay, the n in this case. So the difference is let's say I plug in n equals 1,000,000 to both these two methods. Here we're going to have a single method frame in our stack with 3 variables, whereas here we're going to end up with 1,000,000 different method stacks, each with their own variable. Okay, it would be pretty easy to put in a big number and crash your Java, okay, just with this simple solution. Okay, so there's a lot of reasons not to use recursion. Okay, why should you use it though? In many cases, recursion allows for a simpler solution to that problem. Okay, that's the big thing I want to try to get across today. I want to show you a few examples of problems where solutions with loops, I'm not even sure how you'd write them, but you can write a simple solution through recursion, okay, that makes actually writing the code pretty simple. Okay, as far as when to use recursion, when not to, okay, if a recursive solution seems natural, use it. Okay, otherwise, if just the loop seems like it's going to be easier, use the loop. Okay, so again, you never have to use recursion unless we're telling you to write recursive methods like today. Okay, but hopefully I'm going to give you some examples where recursion feels natural. All right, so let's take a look at some examples where recursion makes sense. Okay, so for example, finding all permutations of a string. So by permutation, we're just talking about an ordering. So for example, if I have the string ABC and we want to figure out all the different ways we can order those 3 numbers, it's a pretty straightforward problem to do by hand, just by thinking about. Basically, you choose a first letter, A, B, or C, and then for each of those first letters, you choose a second letter, and then for each set of second letters, you choose a third letter, and you come up with that. Okay, I've actually done this with my daughter in 1st grade. She's come up with all the permutations of, I think it was probably colors, but has done this. Okay, as far as coding this though, without recursion, Ooh, that'd be tough. Okay, for this example, what will we need? We need a loop to go through all the possibilities for the first letter, followed by a loop within that to go through all the second letter, followed by a loop within that to go through all the third letters. And the problem is that program we made with 3 loops within each other would only work for 3 letters. Okay, if I want to do this for 4 letters, I'd need a completely different method with 4 loops within loops. Okay, I wouldn't know how many loops within loops to have, okay, based on how many letters I have. Okay, I'm going to say this is a problem that would be an absolute nightmare without recursion. Let's show you the code with recursion. Okay, with recursion, this is it. Okay, it's about 10 lines of code here. So we've got the method print permutations, and it's going to accept a string for the string that we want to permutate. And then this is a little ugly here. This is kind of hard to give you on a slide, but I'm going to have a second parameter for the answer. It's going to start off as an empty string, and then we'll be adding to that as we call our print permutation method again. Okay, a nicer way to write this program would be have an overloaded method where if I just plug the string in, it automatically plugs in the empty string for the answer. Okay, but we plug in our ABC and then an empty string. And then what we're going to continually do is take letters from that string that we plug in and move them to our answer string, which will be printed out here. Okay, so our base case then is once our string has a length of 0, so in other words, as we've taken all the letters out and added them to answer, that's when we'll print answer and we'll return. Okay, so that's our base case when answer is full and the string we start off with is empty. Okay, otherwise what we'll do is we're going to loop through the length of the string. We're going to take a letter out, okay, the ith letter out using a substring. So for example, as I is 0, we take out the first letter. When I is 1, we take out the second letter. I is 2, we take out the third letter. We're going to come up with the rest of the string just by removing, okay, so substring to the I and then everything after the I, that ith letter we remove. We'll call that the rest, we'll call that the letter, and then we're just going to run our method again on the rest and the answer with that letter added in. Okay, so our answer initially starts empty, and then we add that letter as we go. Okay, it's a lot. It feels like magic sometimes when you're writing these methods. We'll write one together in a few minutes. Okay, but this would work. This would actually give you all the permutations. Basically, we have the stop case, and then here's what we do to make the next call. Okay, so again, I have no clue how many lines of code this would take to write without recursion. It's actually pretty simple to write with it. Okay, let's take a look at a few more examples, and I'm not going to actually throw some code up for these just because there's no way I could fit them into a slide. But merge sort, that's something we mentioned when we talked about our sorting algorithms. Basically, the idea is pretty simple. If you start with an unsorted list, split it into 2 lists of equal length, and then split each of those 2 lists into 2 lists, and then split those down until we get to single lists. So split everything apart, and then we go and merge them back together, and each time I do a merge, I'm going to put things in the right order. So the 5 and 3 I'd put in the right order, the 4 and 1 I'd put in the right order. Then as I put these 2 chunks of my list into one big list to be sorted, we'd sort this half of the list over here until eventually we have 2 sorted lists that we'll put together in a single sorted list. Okay, as far as time goes, this is actually the fastest way you can sort a list that has the least amount of steps. Okay, we looked at this picture before. As the numbers get huge, as the numbers we're sorting get huge, our merge sort greatly outperforms the insertion sort and the selection sort we looked at earlier. Okay, now as far as going back to this process here, it's very recursive in nature. The actual code for this is a little nasty, but I'm not sure how the heck you do this without recursion. Okay, so that's another example of when recursion makes sense. One final example for you, and this is from my own coding exploits here. This is a problem I'm actually working on just for the heck of it. Okay, getting through a maze. Let's say I had to navigate through this maze of 1s and 0s where I can cross the 0s. Okay, I can't cross the 1s, and I need to find the path that works. I need to find the directions that work. Okay, I have tried to write this without recursion. I got to about 300 plus lines of code, and It just wouldn't work for all cases. Okay, a recursive solution is the best way to do this. It's the best way when we need to make multiple decisions and go through different possible combinations. Okay, so going through a maze would be another case where a recursive solution makes the most sense. My battery's dying. All right. Let's write a recursive method for another situation where I'd say recursion makes sense. Find the nth Fibonacci number. Remember, our Fibonacci sequence follows the rule that the first number is 1, the second number is 1, and then each number from that is the sum of the previous two. So for example, I have a 1, a 1. The 2 comes from 1 plus 1. The next number 3 comes from 2 plus 3. The 5 comes from 3 plus 2. The 8 comes from 5 plus 3. Okay, that definition I'm giving you is recursive. It's a lot easier to write this type of solution to find the nth Fibonacci number as a recursive solution. So let's go ahead and do that quick. We'll say we're writing the method public static int nth fibnum, and we'll plug in an int n, and that's going to give us the nth Fibonacci number in that sequence. Okay, now basically writing a recursive method, there's two things you need to come up with: the base case and the recursive case. All right, so what is my base case? When does this method kind of stop working backwards? Well, that's when n is 1 or n is 2, the first two numbers. I know those are just 1, so what we'll do is we'll just say when n is 1 and n is 2, return 1. Okay, so if I want to know the first Fibonacci number, this method just gives me a 1. If I want to know the second Fibonacci number, this method just gives me a 2. Okay, the recursive case then, the next number is the sum of the previous two. So all I'm going to do is say return the nth Fibonacci number of the next one down plus the nth Fibonacci number of the one before that, n minus 2. That's it. That's all there is to the solution. Okay, I've heard it described as kind of a recursive leap of faith where you just have to trust that the computer is going to make the right things happen. Okay, but basically, again, that's it. It tells me what 1 and 2 are, and then it tells me the nth one will just be the sum of the two before that. All right, so if you go on Moodle, there's a link to CodeBoard where it's going to take you to a couple simple recursive methods to write. Okay, give them a shot. Do the best you can with them. Send me an email if you're stuck on something. We'll try to fix your code. This is an advanced topic. We don't expect you to be masters of this even after this course. It's something that will come up in further computer science and programming. So it's something we want you to practice a little bit. Give it a shot. Let us know if you need help.